Welcome back to the second and final installment on our lesson from section 12.2. Where we're going to continue to look at the graphing of exponential functions. So what I'm going to do is I'm going to write both of these down and talk about and discuss how they're related. So the two graphs that we're going to put down here are going to be problems 16 and 18. So problem 16 and 18 will go here. Problem 16 is going to read y is equal to 2x, 2 to the x, plus 1. And then question 18 will be y equals 3 to the x minus 2. And what we're going to do is we're going to talk about how by either adding 1 or subtracting 2, what is that doing exactly to the original function of just 2 to the x or 3 to the x. So we got to see the behavior of those first two functions. So again, here what we're going to do is we're going to create a table of values that's going to be graphable. So I'm going to go ahead and just do that down here. Remember, for your homework, you need to write the function, you need to give me a graphable table of values, and then you need to make a graph. So this is going to be x, this is going to be y. And for this one, we can kind of stick with normal values. So we're not going to make any changes to our standard 5 values, which will be -2, -1, 0, 1, and 2. So this is going to be 2 to the -2 plus 1, 2 to the -1 plus 1, 2 to the 0 plus 1, 2 to the 1 plus 1, and 2 to the second plus 1. Now, for the purpose of this, I'm not going to focus on the intricate calculations, which can be a little cumbersome for this. I'm going to go straight for the answers. The calculations you should be able to do for yourselves, but if you have any questions on those, just go ahead and see me in class. So for this, 2 to the -2, like we showed in the last video, is going to be equal to 1 over 4. And 1 over 4 plus 1, that will equal 1 1/4, or 5 over 4. Okay. 2 to the -1 is going to be 1/2. 1/2 plus 1 will be 1 1/2, or 3 over 2. 2 to the 0 is going to be 1, so 1 plus 1 is 2. 2 to the 1 is 2, plus 1 will be 3. Then 2 to the second is 4, and 4 plus 1 is 5. So we now have 5 points we can put down here. And for -2, we just want to be just a little above 1 now. Excuse me. Let's see. For -1, we're going to be just like at 1 1/2. For 0, we're going to be at 2 this time. For 1, we're going to be at 3. And then for 2, we're going to be at 5. So we'll go ahead and put those down there. And then again, let's go ahead for this one. We have 3 to the x minus 2. Let's see what happens at this function. We make a graphable table of values. And I should mention here, this is going to be where 2 to the x exponent plus 1 goes. Here is where 3 to the x minus 2 is going to go. And I'm going to come up with 5 values here. -2, -1, 0, 1, and 2. So this would be 3 to the -2 minus 2, 3 to the -1 minus 2, 3 to the 0 minus 2, 3 to the 1 minus 2, 3 to the second minus 2. The first one's going to be pretty easy to see. For example, 9 minus 2 will be 7. 3 minus 2 will be 3. Yeah, minus 2 will be 1. 1 minus 2 will be -1. So you see it's kind of going down, and it's actually going below the x-axis here. Well, 3 to the -1 is 1/3. 1/3 minus 2, what's going to be -5 over 3? Now we have here 3 to the -2, which is 1/9. 1/9 minus 2, this is actually going to be, so we have 1/9 minus 2, actually going to be -17 over 9, which is really close to 2. So let's just kind of see what this is going to look like here. So this is going to get close to 1, but never quite get there. Kind of graph it up like so. The other one here, when I plot the points down, this is going to get really close to -2, but never quite get there. This will be like this. -5 over 3 is still going to be pretty close to that. Then it crosses here at -1. Then it crosses up here at 1, and this crosses all the way up at 7. So we're going to have a graph that looks like this. And yeah, it begins to climb up quickly again. So what we're going to do is go ahead and we're going to kind of compare the graph of 2 to the x to 2 to the x plus 1, and then we're going to compare a graph of 3 to the x to 3 to the x minus 2. And let's talk about what these numbers are doing here in relation to the graph. So I'm going to turn this on now, go back here, and I'm going to go ahead and make this 2 to the x plus 1. I'm going to go here, I'm going to make that 3 to the x, and down below I'm going to make that 3 to the x minus 2. We're only going to graph the first two of these though. And then later what we'll do is we will go ahead and then graph everything together. So let's kind of change that back to a regular line. Whoops, I had that. There we go. And then we'll make this one a thick line here. I did have that. Okay, so we're going to graph the first two first. Let's see what happens to the graph. So the first one that's going to graph is going to be 2 to the x. The second one that's going to graph is going to be 2 to the x plus 1. The graphs are going to look close on top of each other, so let's go ahead and let's adjust the window here. So instead of x max going to be 30, let's go ahead and make this 10. Let's adjust that y min to a negative, let's make a negative 4. And let's go ahead and, whoops. Somehow it didn't like what I did. And I didn't like what I did either. So I'm going to try this one more time here. Let's adjust the window again. X min is negative 10, x max is 10, the x scale is 1. Y min, oh, because I made the y max 1 instead of 10. Let's try the graph of this now and let's see what happens. So the graph looks the same. All I guess that happens is if we look at the table, is that each of these values is 1 higher. When this is 2, this is 3. When this is 4, this is 5. When this is 8, this is 9. So let's go ahead and go back to the table now. We're going to turn these graphs off. We're going to go ahead and turn these two on. And let's compare the difference of 3 to the x with 3 to the x minus 2. You may even have a guess about what's going to happen with this here. So we go ahead and we grab the first one. And it looks like the second one is coming. Ooh, it looks like it's coming a little underneath. Let's go ahead and take a look at the table and see what's happening. So when we look at the y value for the first graph, this seems to be 2 less each time, which is in fact what's kind of going on. So what these values do here, the plus 1 and the negative 2, is they're going to cause a vertical shift in the graph. So that's going to cause the graph to either go up or is going to cause the graph to go down. So by vertical, we're talking taking the graph and either going up or causing the graph to go down. So this is one way in which we can change like the generic graph of like 2 to the x or 3 to the x. You know, we can shift it up or down by just adding something to the function altogether. So let's go ahead and take a look at a few different functions here and some few different ways that we can adjust them. So we're going to take a look at two other functions now. We're going to take a look at functions 20 and function 22. And this is going to be y equals 2 to the x minus 1. So x minus 1 is the exponent. Here we have 2. And this is going to be 2 to the x plus 1. So this one's a little different because it's a switch in the exponent here that's actually going to cause us to use different values when we're plotting this. So this is one in regards to the tables that you probably are going to want to star because we're not going to use the same values in the table that we've used for the other graphs. And that's going to be true whenever we are making some change to the exponent other than simply x. So let's look at criteria for what kind of change we're going to make and how we adapt to it. So this is going to be x, this is going to be 2 to the x minus 1, and this is going to be y. So what I'm looking for here, I want the middle value, just kind of like the work when we're finding the vertex of a graph so we kind of know how to graph a parabola here. I need to know what value is going to make the exponent 0. So I'm going to set that exponent equal to 0. And when I do that, I find that if x equals 1, that's going to make the exponent 0. So that just helps to kind of establish what values I want to use here. So I'm going to go ahead and use the value of 1 in the middle here, and that I get from this. Let's do something similar with question 22. So we're going to create the graphs like we did before. And here we have 2 to the x plus 1. I need 5 values to come up with a plottable set of values. And I'm wondering, what's going to make this exponent 0? So I'm going to take x plus 1, and I'm going to set it equal to 0. If I subtract 1 from both sides, I get x is equal to negative 1. And I'm going to put negative 1 in the center here. So over here I got positive 1. Over here I got negative 1. And now from 1 I'm going to go to 0 to negative 1. And then above here I'm going to go 2 and then 3. Over here from negative 1 I'm going to go 2 above that, which is going to be 0 and 1. Here I'll go 2 below that, which would be negative 2 and negative 3. And we'll see how each of these are going to graph now. So this is going to be 2 to the negative 1 minus 1. This will be 2 to the 0 minus 1. It's going to be 2 to the 1 minus 1. This is going to be 2 to the 2 minus 1. This is going to be 2 to the 3 minus 1. Well, that's going to be 2 to the negative 7, so that's going to be 1 over 4. This is going to be 2 to the negative 1, or 1 half. This will be 2 to the 0, which is going to be 1. This will be 2 to the first, which is going to be 2. This will be 2 to the second, which is going to be 4. So we're going to plot the following points in this way now. So we're going to plot negative 1, 1/4, which is pretty close here. 0, 1 half. It doesn't have to be exact, but, you know, kind of close. 1, 1. 2, 2. And then 3, 4. That looks like it almost doesn't make sense, but yeah, that's about right. If you were to plot the point 4, you would get 4, 8. Now, you don't have to get that, but just to give you kind of an idea of what this is doing. And it doesn't look like it's going to cross the x-axis, and it won't. And you could graph that on a graphing calculator on the computer if you'd like to just verify that to check to be true. Here, if we create the table of values for this here, you would find that, and without evaluating this, you can do this yourself if you want, but this will give me 1/4, this will give me 1 half, this will give me 1, this will give me 2, and this will give me 4. So I'm going to go negative 3, 1/4, negative 2, 1 half, negative 1, 1, 0, 2, and then 1, 4. So these look similar. If you look at the y values, they sure look like they're about the same. Is what we're getting over here, but the x values are clearly different. So again, I didn't do all the number crunching here, but I will expect to see that on your homework, at least doing the substitutions in there. So what I'm going to do now is I'm going to go ahead and graph the graph of 2 to the x, and then 2 to the x minus 1, and then 2 to the x plus 1. So let's go ahead and turn, whoops. Just warming up here, I guess. Sorry, I didn't realize this had turned off when it takes so long to warm up. Okay, so we're going to leave the graph of 2 to the x here. Then we're going to have the, we're going to do here to get this x raised to an exponent, we're going to make this 2 to the x plus 1. And then down below, we're going to go ahead and make that 2 parentheses x minus 1. Get that closed, and we're going to go ahead and just clear that out. So this time I'm going to use, we're going to graph all these, and we're going to graph them all at the same time. But this time I need to just change the line of this. And we're going to make this one the turtle, so you can kind of see that graph slowly. When we take a look at the window, I don't think we need an x-min of negative 10. I think an x-min of negative 5 should be okay. I think an x-max of 5 should be okay. We can get rid of that 0 there. Okay. for a y min, we can go with negative 4, and I think y max of 10 will do. So let's go ahead and let's graph these. So the first graphing you see is just 2 to the x going up like the other one does. Here's a graph of 2 to the x minus 1. That's the thick one. And let's take a look at the graph of 2 to the x plus 1. It seems to be coming low underneath. And that is graphing to the right. So let's just make sure I put those in. Oh no, I'm lying to you. So let's take a look at these in the same order here. So it's going to be minus 1. Let's go ahead and change that to a plus. Whoops. Go over here, 2. Oh, so the first graph we're going to see now is going to be 2 to the x. So now when we type in the graph of 2 to the x minus 1, the shape of the graph looks the same, but it looks like it's been moved over to the right. We have the graph of 2 to the x plus 1. And indeed, it looks like it's moved over 1 to the left. So what we can say based on the graph here is, here's the original graph of 2 to the x. Here's the graph of 2 to the x minus 1. And here's the graph of the line 2 to the x plus 1. Is what we can say about when we add or subtract from the value of the exponent, this causes a horizontal shift. In the graph. So it's going to cause the graph to move left to right. Like in the previous two examples, we observed that by adding to the function itself and leaving the exponent alone, we can cause the graph to move up or down. Where by adding to the exponent, we actually cause a horizontal shift of the graph to move to the left or to the right. Please also note here that when we are changing the value of the exponent by adding or subtracting, and this will be changed also, so by adding or subtracting, that it will impact the values of x and y that we put into that. So, okay, we're going to take a look at just a couple more examples to see how this impacts here. And that's going to come in the form of some equations that are written in fractional form. So this is going to be 24 and 26. And this is going to be 1/4. This is y equals 1/4 to the x. And then 26, which is going to be y equals 1/3 to the x. Okay, so let's see what happens here. I don't know if you can kind of see what's going to happen with this yet, but we will make our table. 1/4 the x. This will be y. X 1/3 to the x. Oops, to the x, not this one here, and then y. Then we don't need to change our values here. We're just going to put our regular values in: -2, -1, 0, 1, and 2. -2, -1, 0, 1, and 2. So this would be 1/4 to the -2, 1/4 to the -1, 1/4 to the 0, 1/4 to the 1, 1/4 to the second. This will be 1/3 -2, 1/3 -1, 1/3 to the 0, 1/3 to the 1, 1/3 to the 2. I apologize if that's small, but if you can copy that down in a size that you can read, hopefully that's going to make more sense. If I raise 1/4 to the -2nd, I got to flip this. So -1/4 flipped is 4. And then 4 squared, that's going to give me 16. So that's going to be a value we're not going to be able to plot actually, but it should give us an idea of the direction. 1/4 to the -1, to get rid of the negative on the exponent, I flip it, and then make it 4 to the 1, which would be just 4. 1/4 to 0 would be 1. 1/4 to the 1 is 1/4, and then 1/4 to the second is going to be 1/16. So when we graph it, we get something like this. Well, this is going to be way up here. -1/4, 1, 1/4, 1/16. So all of a sudden, the graph seems to be behaving quite differently. Let's take a look at these other values here real quick. 1/3 of the -2nd. If I flip 1/3 to get rid of the negative on the exponent, it's going to become 3. And then 3 squared will be 9. this is going to become 3. 1/3 of the 0 is 1. This would be 1/3. 1/3 squared is 1/9. Well, all of a sudden here is -2, -9, -1, -3, 0, 1, 1 1/3. And some people may be kind of seeing what's happening here, and I don't think I have to go in any great detail of what's happening to this, but the way we characterize this is as follows. When the base is less than 1, the graph flips, or is reflected over the y-axis. So what you see here, this would be the reflection of 4 to the x. This would be the reflection of 3 to the x. So these are the main things that cause a graph to change. And when you see these questions on your next quiz, your final or next half test or final exam, you should be ready to recognize and anticipate what kind of changes are going to be made. If you can't anticipate them necessarily, certainly coming up with the table of values should help you generate those. So just remember, for your homework, I'm going to look for the function itself. I'm going to look for a graphable table of values, and I'm going to look for a general sketch of what the graph is going to look like, what the shape of the exponential function is going to look like. See me in class if you have any questions. Thank you.